Now that we've had a little practice just using the annuity formulas, let's put it into some context, all right? Let's put it into like a real life kind of problem. This says, suppose between the ages of 25 and 37, you're contributing $200 per month to a 401k and your employer matches the contribution 100%. If the interest rate is 6.4% compounded monthly, what is the value of the 401k after 12 years? Well, let's see. The time, N, number of years, is 37 minus 25. Yes, it says 12 years. That's what we come up with between 37 and 25. We also need to know what our deposit is. Now be careful here. It's not just 200 that you're putting in. Note that we have 100% match from our employer, so 200 plus another 200 means we're depositing 400 a month. What else do we need to know? We need to know K, the frequency of compounding. Well, it says compounded monthly. We're depositing monthly. That should always match. And the last thing is our rate. R is 6.4%. Move the decimal twice, and you get 0.064 for the rate. All right, we'll put all of that into our formula for P sub n, that big old fraction, the annuity formula here, and then carefully put it into our calculator, and we should come up with approximately $86,329.26. Okay, if you have trouble with the calculator, double check that you're putting in all these parentheses. For the exponent up here, 12 times 12, either do that in your head or put that in parentheses as well. If you're still not getting it, please let me know and we'll try to sort that out. Okay, so as happens, people change jobs. So after that 12 years, we're going to suppose we change jobs, but that money is just going to sit in that account earning the same type of interest rate. We want to know how much will be there at age 65 when it's time to retire. This is not an annuity anymore, right? Because we're not putting deposits in. Annuities require a regular deposit. Instead, we have a lump sum of money that's in this account that's just going to be getting compound interest. So we're back to the straight compound interest formula. The one thing we have to calculate here is, what was the age we left the company? It said just a moment ago, 37. And we're going to be leaving this in our account until we retire at 65. So we are going to calculate N to be 65 minus 37, or 28 years. The rest of it is just following the formula. P sub N is equal to P sub 0, the initial deposit, times the quantity, 1 plus R over K, raised to the NK. That's the basic compound interest formula. Putting in the 86,000 plus that we just calculated, and our interest rate, and our frequency K of 12, and our N of 28, we're going to come up with approximately $515,638.97. That's over $500,000 that you will have sitting in that account. Now here's where it gets really interesting, I think. The next question is, how much did you actually contribute to that 401k? And how much then is interest and benefits? Well, the first part of the problem said we were going to be contributing $200 every month for the course of 12 years. So 200 times 12 times 12 years is $28,800. That was our part of the investment, or your part, however we're reading this. So very small amount. Then to calculate the interest and benefits, we're going to subtract that from what's eventually in the account, 515,000 plus minus our 28,800. That means the interest earned and benefits from our employer was $486,838.97. That's a tremendous amount. Okay, moral of the story here, take advantage of employer matches and start early with your investing, because just invest it a little bit early on and let it sit. It'll grow quite a bit. Our retirement projects, I'm going to be using some of these formulas as well. So as you're working through the homework, pay attention. What formula am I using here? How did I know that formula? And you'll see you're building up to the project we're going to do. It's not going to be anything crazy. It's just going to be all put together into a single assignment. Let me know if you have any questions.